here we're modeling data with a linear function. So again, we have the formula f of x equals ax plus b may be interpreted as follows: f of x equals mx plus b, because m is more in line what we always have learned. That's our slope, okay? So this is our change. This is the fixed amount. So if we think about this in costs and stuff, b is going to be our fixed cost, and then this is going to be our changing cost, depending on how many things we build. It's going to cost this much to build each one, and then this is going to be our total cost. So we could look at it as something in the real world in a business, for example. Okay. So an x represents time. Change equals the rate of change times time. And so, rate of change times the time plus our initial point, that's going to give us our future point. Okay. So that's kind of how we're going to model some data. So suppose that a moving truck costs 25 cents per mile. That sounds like some kind of a rate of change or something. So that's probably going to be our M. And we have a fixed rental fee of $20. That sounds like a B. Find the formula for a linear function that models the rental fee. Well, so if we call the rental fee R of, I don't know, let's call it M since it's number of miles, that's going to be our rate per mile, 0.25 times M plus the $20. And again, we can use a lot of different letters, a lot of different function notation, but pretty much it's going to come out the same no matter how we look at it. F of x is equal to 0.25x plus 20. That's our b, that's our m, and then all the rest of it depends on what variables and stuff we want to use for our equation. All right, how about the temperature of a hot tub is recorded at regular intervals? So 0, 1, 2, 3 hours, okay? All right, so notice that at the 0 hour, it's 102 degrees. So that means that's going to be our B. And we're supposed to discuss the temperature of water during this time interval. Well, it's all the same no matter what the time is. So we haven't changed anything. So there's no change of intervals. It's constant. Okay. So basically, what we're going to do to find a constant formula is it's just going to be y is equal to 102 or f of x equals 102 because there's no change. And how that would be is, again, the difference here is zero. The difference here is zero. The difference here is zero. Now here, the difference is one, one, one. So we're seeing we're having a zero change out of one, which is zero. So that's going to be our slope. And so f of x equals 0x plus 102. And so 0x is just that. So f of x equals 102. And hence, that's why we can say it's 0x plus 102 because we found the slope, plugged it in. 0 times anything is 0, so we just have 102, and that's our f of x. And so that's how we can plot data that's actually a constant. And if we actually had graphed that, it's going to look something like, this is 102, so it's going to do something like that. Okay. At least out to 3 hours. We don't know what it does beyond that. Maybe all of a sudden it drops temperature or goes up or it stays constant. We don't know. All we can say is between 0 and 3, that's what it's doing. All right, now the temperature of the hot tub is recorded at regular intervals. Sketch a graph of the data. Well, that's kind of what we did here. We did it here. We said 0 starts here, 1, 2, 3, and that's what we show here: 0, 1, 2, 3, and that's our data sketched. All right, let's stop there and we'll come back for some more.